Alright, so I am going to ask you a algebraic question. Given the fact that f of x is equal to x cubed minus 5x squared plus 3x minus 10, given that fact, I want you, and I think you can do this, and I think you can do this in like 2 minutes actually, I want you to find me f of negative 2, and I want you to find me f of 3. Go. Anybody want to go out on a limb and tell me what they got for f of negative 2? Take a chance. Columbus did.
I got negative 44.
You got negative 44. Anybody else get negative 44? Why don't you guys take a chance? Because I got negative 44. Okay. F of 3. What do we get for f of 3? Carter, what'd you get?
Negative 19.
Negative 19. Anybody else get negative 19? Yeah. Too bad we don't have chance takers, because we'd have a lot of success then. So let's talk about how we actually did that. How did we actually do that? How did we come up with negative 44 and negative 19?
Plug in negative 2 and all the x's.
You know, for all the x's, right? Okay, so you went and you said, well, I'm going to take negative 2 to the cube power, and I'm going to take 5. Whoops, I almost put x there. And I'm going to have to take 5, and I'm going to have to multiply it by that. I'm going to have to square it. I'm going to have to take 3 times negative 2, and the last I'm going to have to subtract 10. And then we're going to say negative 2, negative 2, negative 2. And then you got, so negative 2 cubed, well, that is negative 8. And then negative 2 squared is 4 times negative 5 is minus 20. And then that's minus 6. And then that's minus 10. And then negative 8 minus 20 is negative 28. And then minus 6 is negative 34. And then minus 10 is negative 44. Boom, done. All right, love it. Okay? Huh? Do you need a calculator for it? Huh? We can just do that. You know, we can do this, this, that, and here we'd go 3, and we'd go 3, and we'd go 3, and then we'd say that this was 27 minus 45, that's negative 18, and then plus 9 is negative 9, and then minus 10 is negative 19. Yeah. Now, there's an easier way to do that, and that's called synthetic substitution. Now, we said that f of negative 2 was negative 44. So this number out here, this is the number that I am evaluating. And these numbers in here, these numbers, these are the coefficients written in standard form. Refresh my memory from a polynomial. What does it mean to be in standard form? Because that's kind of big, if those coefficients have to be in standard form order. What does it mean to be for a polynomial to be in standard form?
All the variables on one side.
Even more than that. I'll give you a hint. F of x is in standard form.
Oh, equals.
Nope. Standard form of a polynomial. Don't know? Look in your notes. Three 3.2. Standard form. First slide. Third thing you wrote down for 3-2. Standard form. The terms are in
Biggest exponent first from left, right?
okay, so descending order of exponents. So biggest exponent comes first, then next biggest, the next biggest, the next biggest, the next biggest, and then last comes just the numbers. Okay, so that's standard form. Gotta be in standard form in order to do stuff synthetically. Okay, that's crucial. Okay? Then you've done some synthetic substitution / synthetic division before. Drop the first one, multiply, so that gives me -2. Add those two together gives me -7. Multiply by -2 gives me +14. Add those two together gives me 17. Multiply by -2 gives me -34. Add those two together gives me -44. So this right here tells me that f of -2 is -44. Likewise, f of 3 we said was just -19. So 1, 3, -2, -6, -3, -9, -19 tells me that f of 3 is -19. What I'd like you to do now is I'd like you to use that synthetic substitution, and I'd like you to find me what f of -3 is and what f of 4 is in this new function. This is now a new function. I got f of -3 is -84. Agree with that? Okay. I got f of 4 as 0. Yes? Okay. So that means a couple of things. When you get a result there of 0, that means a lot of different things. So first off, that means that 4 is a 0, because when you plug it into the function, you get out 0. That means that 4 could also be called a root. 4 could also be called an answer or a solution. To f of x. Okay. The other big thing is the fact that x minus 4 is a factor of f of x. If 4, it's kind of like you're working backwards. Okay? So if 4 is a 0, so that means at the end of the problem, if you were solving this one, you would have gotten x equals 4. But the step right above that would have been x minus 4 equals 0. And the step right above that would have been x minus 4 times something else equals 0. And the step right above that, if we're working backwards, would have been x cubed, what was it? X cubed minus 6x squared plus 5x plus 12 equals 0. Because we've been solving like that, where we've been factoring first, but this one's not factorable. So we couldn't factor it, so came up with a new way to do it. Okay? All right. So let's make things a little easier on ourselves. Okay. You've been wanting to do it for a while now, so let's do it now.
Wow, you guys really love that old school long division of polynomials. But if you had a fancy way, yeah, like ketchup, right? I'm talking about maybe motor oil. Synthetic motor oil? No, synthetic division. Yes. Here's our topic. Right. What do we need to do? We need to be dividing by special linear factors in order to use synthetic division. So let's talk about how we're going to get into this game. All right. Special linear factors. Yeah, something like these guys. Okay. This is not a special linear factor. Why? Because my leading coefficient of my variable is not 1. What makes a special linear factor? A special linear factor has coefficient 1 and degree 1. An example of a special linear factor is x minus 2. Okay, this is x minus c. Okay, what goes outside of our box? The opposite of c, or whatever's going to make our denominator 0. I'm ready for an example. Here. Yes. And I'm divided by a special linear factor. Yeah. So then, okay. Zeros go outside of the box. What makes that denominator 0? Minus 1. Zeros go on the outside. Coefficients go on the inside. Coefficients are the numbers in front of the variables. Here we go. I'm going to put a 1. I'm going to put a 3. And I'm going to put a 2. Oh, this is actually long division without the actual coefficients, and we need our special linear factor. So then what do I first do? Drop it like it's hot, drop it like it's hot. Minus 1 times 1 gets me a minus 1. Very nice. 3 minus 1 is 2. Okay. Minus 1 times 2 is a minus 2. Oh, and our remainder is 0. What does this mean? This means that x minus 1 is a factor of x squared plus 3x plus 2. You're going to be using something called the factor theorem to determine that. Yes. But that's neither here nor there. Where is it? Yes. We're taking 1 degree out of the numerator. It was a degree 2. So now I want to write my answer as 1 degree less than 2, which is 1. X plus 2 is going to be the quotient of those two polynomials. And then what? And a flower. Now I'm up here. Okay. Yes. Am I dividing by a special linear factor? Yes. So what goes on the outside? Zeros go on the outside. What's a 0? Anything that makes that polynomial 0. What's going to make this polynomial 0? 1 is. Okay. And, a different color. Yeah, 1 is on the outside. What goes on the inside? My coefficients. Yes. A 1 goes in there. A 2 goes in there. A minus 3 goes in there. And a 12 goes in there. Okay. So then, I drop it like it's hot, drop it like it's hot, you know, yeah, whatever. That was my song with one of my ex-girlfriends. Yeah, and, yeah, I went away, and, I'm not gonna finish that story. Anyway, she dropped me like it was hot. Oh, messed up, right? She was a horrible person. No, she wasn't, really. Yes, here's a 1. This one times that one, put it there. That's a 1. 2 and 1 is 3, Tiki. This one times that one, put it there. That's 3, Tiki. None. Yes, this one times that one, put it there. 0. Oh, Adam, and you got 12. Oh no! What does this mean? Let's go through it. Rewrite our quotient. Yes, I had degree 3. This is gonna take it down a notch. I wish you'd take it down a notch. Hey, whoa. So instead of degree 3, it's now gonna be degree 2. So then, this is going to be x squared plus 3x plus, no constant, but I do have a remainder. And how do I write that? I write it remainder over divisor x minus 1. Fine. And then what? And a flower. And when I said I went away, I wasn't talking about like the yeah, no, I had to go, do some work somewhere else. Here we go. What makes this denominator 0? 2. Yes. So I put a 2 on the outside. And then I put the coefficients on the inside. I put a 1. Then I put a 0. Why? Because I need a placeholder for my x to the third term. Yes. So 0x to the third plus 0x squared minus 1x plus 2. Okay. Oh, I need placeholders. On the outside, zeros. And then on this first one, drop it like it's hot. There's a 1. 1 times 2 is 2. Very nice, Adam. 2. 2 times 2 is 4. Short, Adam. 4. 2 times 4 is 8. Great, Adam. That's a 7. 2 times 7 is 14, Adam. That's a 16. Okay, that's my remainder. I'm dividing by a linear factor. I need to take it down a notch. This is x to the third plus 2x squared plus 4x plus 7 plus remainder 16 over divisor x minus 2. Look at that one. Oh, yes. Yeah, I do think it's a hammer. Because it's hammer time? No. Because we nailed it.
Oh, no need to play it again. Okay? Alright? So, what that's saying is, we got our function. Okay? F of x equals x cubed minus 6x squared plus 5x plus 12. So since f of 4 equals 0, that means x equals 4 is a root 0 solution, answer, all that stuff. And x minus 4 is a factor. Okay? So we can use synthetic division now that we know that we have a 0 or we know that we have a root. We can use that to help us along to get to one of 3 stops along this way. Okay? So I think about it like this. If you've ever ridden a bus, okay? Anybody ever ridden the city bus here in town? Okay? Right? You have stops along the way, right? Okay? Somebody will pull the chain and you stop. Okay? Or it has a predetermined stop of like on the street corner somewhere. Okay? Right? So you can predetermined stop or you got other stops. Well, we're going to have nothing but predetermined stops. Okay? First stop is going to be, we are going to just straight up divide out the numbers. Or divide out the polynomials. Okay? So we can use synthetic division in order to do that. So on this stop, the problem would look like, we'll go in here. Okay? So it would look like x cubed minus 6x squared plus 5x plus 12. And then that is going to be divided by x minus 4. The bad 12. Don't like that 12. Much better. Okay? That's what the problem is going to look like. And that's all it's going to say. Okay? And so we've been doing that yesterday or actually up until about half hour ago. You would have long divided those two together. Okay? But now you're going to say, well, if x minus 4 is my linear factor that I'm dividing, I'm going to set that equal to 0. And so I'm going to say that x equals 4 there. And that's the number that I'm going to divide into. And then I'm going to say, okay, now my coefficients are 1, negative 6, 5, and 12. Drop it like it's hot. Multiply, add, multiply, add, multiply, add. Okay. So the answer at stop number 1, when you are just straight up dividing them, would be x squared minus 2x minus 3. That would be the answer at stop number 1. Okay? When you get on the bus, you're following that bus route, no matter where you want to go. Okay? You may want to get on the bus here at Wausau West, and you may want to end up downtown, but the bus probably is going to have to go somewhere before that. Okay? All right? You can't just get on the bus and say to the bus driver, I want to go here. The bus driver's going to look at you and say, you're in the wrong place. Okay? All right? So, no matter where you're going, you're going to have to go through stop number 1. Okay? So you got to straight up divide it. Okay? Then, stop number 2 says, now it's saying we could also factor that one completely. And it would say in the problem, factor this polynomial completely, knowing the fact that this is a factor. Okay? So in this particular one, it would say, knowing the fact that x minus 4 is a factor of f of x equals x cubed minus 6x squared plus 5x plus 12, factor it completely. Well, you divide it out, like we did, but now you would say that f of x here is equal to my first factor. That was the factor that was given to me. X minus 4 is a factor. When I divide it in there, I get x squared minus 2x minus 3. And now you've got to ask yourself, now here, I can see if x squared minus 2x minus 3 is itself factorable. Are there two numbers that multiply together to be negative 3 and add to be negative 2? Yes or no? What are they?
Negative 3 and 1.
Negative 3 and positive 1? Okay, so then this would factor, completely factored, this would factor to x minus 4, x, what did you say, minus 3 and plus 1? Minus 3, and x plus 1. So that's completely factored then. Okay. And the last stop on our bus route, or our destination that we want to go, is stop number 3, where it says, find all the zeros, the solutions, the root, or the answers. Well, in order to do that, I first have to be given, I'm either going to be given a 0 or I'm going to be given a factor, so I'm going to have to divide that out, that's stop number 1. Then I'm going to have to completely factor it, that's stop number 2. And then I'm going to have to find all the zeros. Well, I'm going to build off of that last stop because I had to go through it. So f of x here is going to equal x minus 4 times x minus 3 times x plus 1. And I'm going to say then, well, since it's completely factored, I can set the factors equal to 0. And then I can say that the 3 zeros, because it had a degree of 3, so I needed to get 3 zeros. My 3 zeros are negative 1, positive 3, and positive 4. Okay. You are going to need, I shouldn't say need, you are going to have to read the directions, because the directions are going to tell you which stop you need to make. Whether it's stop 1 where you just straight up divide them, whether it's stop 2 where you just straight up you factor them completely, or whether it's stop 3 where you have to find the zeros. Okay? So there's 3 versions, all of the same problem that I can throw at you for the rest of this unit. Okay? So, looking at this one, which stop is this one? First stop, second stop, or third stop? Why? It just says straight up divide. So we're just going to divide it. Okay? So the first thing that we do is we look at what we're dividing by. We set that equal to 0. And we solve. That gives us our 0, if you will. Okay? So I put that on the outside. On the inside then goes 1, negative 1, 4, and negative 10. Drop, multiply, add, multiply, add, multiply, add. Is x plus 2 a factor?
No.
Why not? Because it doesn't end up with 0. Okay? Anything that doesn't end up with 0 is not a factor. Okay? Luckily, we don't have to factor this one completely. So then what is my answer for this particular problem? Quick. Kid.
So 1x cubed.
Nope. Caleb?
It's x squared plus 3x plus 10, and then it's negative 30 over x plus 2.
Missing something though. What?
Plus negative.
Plus. Yep. Over, you said x plus 2, right? Okay. Remember, Kate, we got to drop the degree, drop it by 1 because we're dividing by that linear term.
Okay.
Yep. Always drop it by 1. Okay? Love it. Which stop is this one? Stop number 2. Factor completely. Okay? Go for it. So this one was a factor completely. So I know that this x minus 3 is a factor. Which means then that x equals 3 is a 0. Right? Okay. So that means I can synthetically divide in the 3. 2, negative 11, 3, 36. Two, 6, negative 5, negative 15, negative 12, negative 36, and 0. Which means then that f of x can be written as x minus 3 times 2x squared minus 5x minus 12. Can 2x squared minus 5x minus 12 be factored? Because if it can, we have to keep going. If it can't, we're done. Okay. So let's try it. What goes in the first spots? 2x and? Nope. Just x. Because those two have to multiply together to be 2x squared. Okay? My choices for negative 12 are 1 and 12, 2 and 6, 3 and 4. One of them has to be negative. The other one has to be positive. So I'm going to go with plus 3 and minus 4. If I do that, then these two give me negative 8x. These two give me positive 3x. Together, those two give me negative 5x. So f of x completely factored would be x minus 3 times 2x plus 3 times x minus 4. If I had to find the zeros, that would be stop number 3. That's the next stop. This one just said factor it completely. Okay? Which stop is this one? Stop number 3, because it says find the zeros, right? Okay. So it says that 1, 0 is 9. That means that x minus 9 is a factor. Two, 18, 8, 72, 1, 9, 0. So that tells me then that f of x can now be written as x minus 9, 2x squared plus 8x plus 1. 2x squared plus 8x plus 1. Factorable. Yes, no, maybe? What do you think, Paul? I say no either. Because 2 times 1 is 2, and then the other one's got to be 1, so the biggest we could get would be 3. Right? So that's a no-go. Okay? So since it's not, so that means that we are completely factored. Now what? If I got to get to zeros. Set what? Set the factors equal to 0. Yep. So x minus 9 is going to equal 0. That's going to give me x equals 9. That's the one that I already knew. 2x squared plus 8x plus 1 equals 0. How am I going to solve that? How am I going to solve that? 2x squared plus 8x plus 1 equals 0 if it's not factorable. How can we solve that if it's not factorable? What is it? You've seen it before. Degree of 2. What do we call those? No, not because if it was perfect square, we could factor it. Q? That's got to have a degree of 3. It's a Q word. What do we call it when there's just a square? The biggest term is a square. You spent a whole quarter on it in algebra 2. You did some of it in algebra 1. We've already done some of them here. Starts with a Q. What? It's a quadratic. Okay? How do I solve quadratics if I can't factor them? groan when I write it down. I can guarantee it. And I'm going to tell you, you're going to have to embrace it. The quadratic formula. Okay. So that's going to be negative 8 plus minus the square root of b squared. 8 squared is 64. Minus 4 times a is 4 times 2 is 8. Times 1 is still 8. All over 2 times a. 2 times 2 is 4. So 64 minus 8 is 56. Square root of 56 simplifies itself to be 2 times the square root of 14. Bunny ears. Got to come out of there. Something does come out of each and every one of those. So that's going to be x here equals negative 2. Oops, nope, tap the brakes. Can't divide by 4, got to divide by 2. X equals negative 4 plus minus the square root of 14 all over 2. So my 2 extra zeros, or my 3 total zeros, are 9 and negative 4 plus the square root of 14 divided by 2, and negative 4 minus the square root of 14, all divided by 2. And there are my 3, almost said 4, there are my 3 real zeros. One of them I knew, and we had to find the other 2. Okay? Your homework this evening is going to be another worksheet. Tomorrow in class, you will get 3 examples on a worksheet and then some homework out of your textbook. Tomorrow will be a hardcore work day, okay? Meaning the quicker you get through the 3 examples tomorrow, the more work time you have. Okay? I, fortunately, will not be here for the second half of class, because I've got to go get on a bus and go to New Richmond. Okay? So, that's why I tweaked the schedule a little bit.